Hello, algebra students. Okay, so now we are working on one of my favorite topics to teach, which is radical expressions. Okay, so they're asking here, what is the simplest form of the square root of 160? Now, here's the important thing to remember. The square root of 160 has a value. This value is something. Well, I could do one thing. I could put it in the calculator, and I can just put this in. I can say, what's the square root? I think this is kind of what we're used to doing. Second square root of 160. Clear. Second quit. Just run the regular screen. Second square root 160, and you'll get a number. 12.649. Blah, 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 blah. It goes all the way down to 649,11064. And actually, it continues past this. This is the only numbers that the calculator shows. It keeps going forever. It's a radical number. Okay, so it's an irrational number. It'll go on forever. So if you give this out as an answer, though it may seem like a very precise answer because of all these decimal places, it is not really. It's not the perfect answer. The idea is to simplify it, but still keep it a radical. Now, if you can make it into a whole number, that's great. But you don't want to really lose the idea of this square root being there. Okay, so you either want a whole number or nothing. Well, not a nothing, or keep it a radical. Okay, so let's think about something. Let's remember our important numbers here. Since the beginning, I've been talking about these numbers that are important to us. 1, 4, 9, 16, 25, 36, 49, 64. After 64, we have 81, 100, 121, 144, 13 squared I think is 169, 14 squared is 196. I'm just double checking my math here. I usually don't go up this high. 196. And if we do 15 squared, it's 225. Now you take the square, these are the key ones. So if I take a square root of any of these numbers, I get a nice even number. Square root of 225 is just 15. Square root of 10. You put any of these in the calculator, you get a nice even number. Square root of 169, we said, was 13. So this isn't really too bad. I'm not going to do all of them because I don't want to spend too much time on this, but just to let you know. Now, this number over here, 160, if I wanted to leave it in radical form, I have to simplify it. This is how I do it. This is my method. I start, this is 160. Now I'm going to start looking at all my perfect squares that are less than 160. So I'm going to take the number 160, and I'm going to divide it first by the first number that's less than 160, 144. Nope. I get a decimal. Keep moving. 160 divided by 121. Decimal. Keep moving. 160 divided by 100. Decimal. Keep moving. 160 divided by 81. Now, normally I can figure this out quicker, but I'm taking this as a fact that we don't know what we're doing. So this is like the best way to get this. You're willing to spend the time on it. Still getting a decimal. 160 divided by 49. Still not there. 160 divided by 36. 160 divided by 25. Still getting decimals. 160 divided by 16. 160 divided by 16 is 10. So that means 160 is the same as the square root of 16 times the square root of 10. Those two numbers multiply together. So, wait a second. So I know this one. Square root of 16, if we remember, or even if we put it into calculator, we know it equals 4. So if I get this, 16 is just 4. And then I just leave this one here, square root of 10. That is it. Now this method may take you a while, but if it's a number, 160 is a pretty big number. So if you get a number that's, let's say 54, which we're going to get later, I would start at 49 and work my way down. It wouldn't be as much work. But this is the fastest way I can think of thinking it right away. Now, some of us may be really good and be able to see this number 160 and say, well, that's really 160 is 16. And if you know your perfect squares, it's just 16 times 10. Some of us may not. Another thing, someone may say, well, 160, they may say, well, I could take 160 and I can divide it by, I'm going to pick a number 4. I'm going to start with a lower number and go up. Well, 160 divided by 4 is 40. So I'll have the square root of 4 and the square root of 40. Okay, that's good. Square root of 4 is just 2 square root of 40. But I could take that down more. So it's like, well, I could also do 40 is really 2 times this. 40 is just 4 times 10. Well, guess what? We got back to that 4 again. Okay? Square root of 4 is just 2. So I have 2 times square root of 10. And now if I figure this out, 2 times 2 is 4, and 4 square root of 10. Just like we did this way. If you notice, the long way is this way. If a number's bigger, you might be doing square root of 4s a whole bunch of times. You might find a whole bunch of 9s in there. If you go from the top and work your way down, you get here quicker. But either way works, okay? But the idea is to have something here, square root of 10, this square root, if I divide it by the last 3 numbers, we have the last perfect squares are 9, 4, and 1. I can't do these. 1 doesn't really count in this situation because the square root of 1 is just 1, so I can't do anything. 10 divided by 9 is a decimal, and 10 divided by 4 is a decimal. So the only thing I can leave that there as is. That's why it's 4 square root of 10. Okay, let's move on to another example. This next example, I'm going to also do the group practice and exit tickets. I just want to look at these. This one is square root of 54 n to the 7th power. Now I'm going to tell you something. If we remember, the square root of n squared, well, that's just n. The square root of n4, I'm picking these numbers on purpose, 4 divided by 2 is just 2, n 2. The square root of n6, 6 divided by 2 is 3. The square root of n8 is just n4. The square root of n to the 10th power is n to the 5th power. Now the problem is 2, 4, 6, 8, 10, those are even numbers. I can only do this with even numbers. But that gives me another option here. If I'm going to move over here. So I could say n to the 3rd is really n squared times n to the 1st power. Remember, keep the base, add the exponents. Well, I know how to do this part. N squared is just n. Square root of n. N square root of n. N to the 5th, well, I know from what we know is that exponents n4 times n1 gives me n to the 5th. Square root of n4, square root of n1. Square root of n4 we know from over here is n squared. And this square root of n because I can't do 1. Finally, the one that's going to play here is n7. I can say n7 is really n6 times n1. Keep the base, add the exponents. Well, n6 from over here we see is n3 square root of n, or n1. That's all you need to know. Now, for this problem, let's look at this. Okay, so I'm here, I'm going, okay, I got this. I got square root of 54 and 7. Square root of 54 and 7, well, that's really two problems. I got square root of 54, and I got square root of n7. We can keep these under here and multiply them later. Well, square root of n7, we just said, from doing this work, is n6 times n1. We take a square root of that. Square root of n6 is n3. Square root of n1 is just square root of n. We'll just leave it as is. We can't do any more. So for this part, I have square root of n6, square root of n1. This comes out to be n3, square root of n. This one. Let's move with this one. Let's look at the square root of 54. Well, square root of 54, I'm going to start doing my method here. I'm going to say 54 divided by the first one of our perfect squares, which is 49. The first one that's lower than 54. 54 divided by 36. I'm only going to stop when I get something that's not a decimal. 54 divided by 25. 54 divided by 16. 54 divided by 9. There he goes. 9 and 6. So this is really square root of 9 and square root of 6. Square root of 9 is one of our perfect squares. The square root of 9 is really 3. So this turns into 3. Square root of 6, I can't break down anymore. The only one I can do is 6 divided by 4. That's going to give me a decimal, so I got to leave square root of 6. Now, if you remember, combining like terms and stuff like that, that's for addition, but here we can do this. The ones on the outside are 3 and n cubed, because we solved those. Now, these on the inside, we can't do anything more with, so I leave them inside. 6n. So 3n cubed, square root of 6n. That's it. Okay, so let's move on to one more problem. This one. Now this problem is kind of a twofold thing. Okay, first thing we got to do is we got to multiply these together. But that's okay. We're going to multiply the numbers on the outside, and we're going to multiply the numbers on the inside. Okay, simple enough. The numbers on the outside, 2 times 3. Well, 2 times 3 is 6. The numbers on the inside are 7t and 14t squared. Now, if you remember, when we multiply numbers like this, when we did this, remember, we keep the bases, we multiply the numbers in front, we break it down. So it's really 7 times 14, the numbers in front, the coefficients, times t squared. 7 times 14, I could do that in a calculator. It's a big number. 7 times 14, I believe, is 98, but I'm going to check. 7 times 14 is 98. So 98, if we remember our exponent rules, t times t squared is t cubed. Now, that's all you had to do to get it to this point. We multiply them together. Simple ideas. Multiply the numbers on the outside and multiply the numbers on the inside. Now, next step. We got to simplify this radical. Now, I'm going to go through this. I'm going to do my method one more time. I'm going to say 98. Well, I'm going to use my perfect squares. The first number that's lower than 98 is 81, divided by 81. Nope. 98 divided by 64 is a decimal. Keep moving on. 98 divided by 49. Boom, there we go, 2. So 98, this 98 is really, let's bring the 6 down, is square root of 49 and square root of 2. T cubed, we're going to make easy on ourselves here too. Now I only could use an even numbered one, but t cubed is really t squared and t to the first power. Let's just use the ones I can do. Well, 6 square root of 49, that's a perfect square. Square root of 49 is 7. So we got rid of that, we got rid of that. We're still multiplying. Square root of 2 I can't do anything with. T squared I can do. T squared is just t. So I got rid of that one, got rid of that one. This one I brought down. Now these two, 2 and t, I can't do anything with, so I'm just going to leave them under the box. 2t, 2 times t. 6 times 7 is 42. So I have 42t square root of 2t. So we took something that looked really complicated, we made it simplified. Keep this one in mind. I think that's the exit ticket, one like this. Okay. Maybe a little longer, but these problems, I like these problems, they're fun. So I'm going to come back with the group practice and the independent practice. Remember, pause the video at some point, write down all my perfect squares here. I wrote them to 15, you can go to 20. Generally, I think everyone should know how to memorize 100 down to 1. So those first 10, or know how to get them. Okay, well, I will talk to you in a minute with the group practice.